We're going to take some time to familiarize you with the major components that you're going to receive from Hypercraft, just to make sure that you have some general definitions and some understanding of what you're going to see and what it's called. This is not supposed to be an exhaustive video that's going to give you all the details and all the workings. That will come later in the user manuals and guides that we'll provide for you. But this will just help you understand what you're looking at and what that item is called. So let's jump into it. This is going to be your motor. Notice that we say motor. When we're talking about electrification, we don't say engine. So this is a Cascadia Motion 225 kilowatt, so about 300 horsepower motor. This is a integrated unit. It has two pieces to it. This bottom part here is the motor, which consists of the rotor and stator. And then up top is your three-phase AC inverter. So this is going to take the DC power coming from the batteries, run it through the AC inverter to give the three phases to the three-phase motor. All of our motors at Hypercraft are going to be AC three-phase, and this will be your workhorse and what actually goes into your truck. We'll talk a little bit later and you'll see it in the model, but this will be mounted in the trans tunnel connected to a gearbox, so it won't actually take up space inside of the engine compartment where your engine is today. So on this face of the motor, this is really the back of the motor. You'll notice a sight glass right here to show the oil. So this is oil cooled on the inside to the heat exchanger, which then goes to the radiator. You have a few sensors and then the main low voltage communication plug here, and that's really this face of the motor. You have your inlet to the inverter for the liquid cooling, which then runs down to that side, which is your heat exchanger. A couple of things that I want to point out and that are important. This is a liquid cooled motor, so it has its own loop, and this is the heat exchanger here. So there will be plumbing that runs from the heat exchanger to the radiator to take away that heat. The heat really comes from the inverter as it's being utilized from the battery packs. And then the batteries, when they're charging, also build heat and have a separate cooling loop. This face of the motor is the business end. This is where the output is from the motor itself, and there will be a shaft that connects to your gearbox. So this motor is 225 kilowatts, about 300 horsepower, but electric, so you get a lot more torque. 368 pound-feet of torque that comes from this motor. And that's before any gear reduction, and we'll go through the gearbox. The gearbox will multiply that torque. That will then go to the transfer case, and then we'll show you what those two look like as an assembly put together. This motor and that gearbox will be in the trans tunnel, and that's where your power will be made. It won't actually be up in the engine compartment where your internal combustion unit used to be. This is your gearbox, and this is what will connect to your motor. This face here mounts up to the face of the motor, and then there's a connecting shaft. This is made by a company called Oberanger. It is a 2.8 to 1 gear ratio gear reduction. So it's a planetary gear set, single speed. So you'll only have the one gear. Remember, with EV, you've got all the torque available from the motor available at 0 RPM. Now we're going to do some throttle mapping and some different programming to make sure that that ramps up, but you'll have all that torque available to you from the motor. On this side of the unit, you'll see that there's a lever here, and this is what engages or disengages your park lock. So there will be an actuator that will move this as you push or shift into gear from drive to reverse to park. This will be activated or deactivated, and then that will allow the truck to move forward or reverse. This will be mated and married to the transfer case to the F-150. So this end will look a little bit different. It's got a flange on it right now, but this will actually get married right up to the transfer case so that you have normal operation of 2- and 4-wheel drive from there. Okay, on this side, you're going to be able to see the cooling inlet and outlet. This is a liquid-cooled unit, and this will be piped to most likely the transcooler that the truck already had, or in line with the motor. So that will be the two different routings, and we will get into that more once the model is done. But it can be done in line with the motor, and it'll be cooled in that cooling loop, and then you'll have a separate cooling loop for the batteries. On this side, you'll also notice that the mounting brackets and provisions are here, and we'll show more detailed designs once we have the CAD model done as to how this is going to mount up. But this unit will be paired to the electric motor, and then this unit and the electric motor will be in the trans tunnel under the truck. And this will be married to the actual transfer case. And that's how you'll get those assemblies to mate up. So this will be your mounting plate and bracket that go from the gearbox to the electric motor. And then you'll have this shaft that will go into the gearbox and then into the motor. And that assembly will go together and again live and be mounted in the transmission tunnel. So you have these mounting plates and this adapter to bring that together. The other end will go to the transfer case. So this is your gearbox, planetary, single speed, 2.8 to 1 ratio that will pair with your electric motor. This is the Hypercraft Hyperpack. So this is one of 6 battery packs that you will have as part of your overall powertrain. And this is a 10 kilowatt hour battery pack that we produce here in-house. We don't make the cells themselves, but everything from the cell level up. So we'll take those cells, we'll put those into modules. There's 4 modules inside of this pack. And then this pack is, some certain voltage. So your system will be 400 volts. You divide that by the 6 packs, and that tells you what the voltage is per pack. We series connect those together through high voltage cabling, and then that builds the overall voltage you need to service the motor. So you'll notice on the front of this, you've got your high voltage connectors here, and then you've got your Molex low voltage connectors here, and that's going to send all the BMS information that's integrated into this pack to the VCU, which is the vehicle control unit. And that is what gives all the data and the important information to the vehicle system that shows up in your display. So you'll know things like what is the temperature of the pack, you'll know voltages, you'll understand the state of charge and the overall health of the packs themselves. So again, this is one of 6 that will be distributed through the chassis of the vehicle. You'll see how that lays out in the CAD model. But this is the battery pack. You've got an inlet for your liquid cooling lines that come in that run to that thermal box that we saw earlier. And then you have a service door here that allows you to have access to the fuse. If the fuse ever blows in a Hypercraft Hyperpack, then we'll service that, but it is serviceable from this port here. Your Hyperpacks also have a high voltage interlock that goes through this low voltage communication line. And what that's going to do is look at the safety and the status of the whole system. And if anything is not right or outside of parameters, it will not allow the contactors, there's a contactor in each one of these, to close. And if the contactors don't close, then the high voltage doesn't flow. So there's safety involved with this through that high voltage interlock, or HFIL is what it's called, and is part of the engineered safety systems in a Hyperpack. Your Hyperpack also allows you to pull from these battery packs to service all of those accessories, including your HVAC system, your compressor, and heater. The Hyperpacks are IP65 rated, so they'll be sealed and secure from any weather or environmental impacts. That covers what a Hyperpack is. These will be mounted into the chassis, and you'll see how those are going to be mounted into the chassis in the CAD model that will be provided. This is going to be your OBC, or the onboard charging unit. It is liquid cooled and it works with the battery loop while the charger is on and the batteries are charging. That's when some heat is developed. So your onboard charger is going to take that heat away from the batteries during the charging cycle. This is a level 1 and level 2 charger, so it will allow you to charge either 110 or 240 voltage circuits. This has a maximum charge rate of 6.6 kilowatts per hour. So if you take your 60 kilowatt hours that you'll have on board, divide that by the 6.6. If your battery's at 0, then this will recharge those 60 kilowatt hours, dividing that by 6.6 kilowatts per hour. This is also your DC to DC converter, so this is what's going to run your 12-volt accessories on the vehicle. The low voltage side of the vehicle will remain at the 12 volts, and the battery that's under the hood, or the normal 12-volt battery that you would have in any vehicle, is just going to be there to wake the computer to turn on the system, and then the whole rest of the system will run off of the high voltage batteries, and then this will give service at the 12-volt level. So your 12-volt accessories will run actually from this DC to DC converter. So it's either 1.5 kilowatts or 2.2 kilowatts of power coming through the DC to DC converter. And that pretty much covers your onboard charger, or OBC, that you'll hear it be called. You can look into the owner's manual that we'll provide, and we'll provide a link to that for more details. But again, this covers the onboard charger, or the OBC, and this connects to your high voltage junction box and is pulling power from the high voltage battery packs. And that covers your onboard charger, or OBC, that will be part of your powertrain. This is your thermal box, and this is going to be important for two different reasons. First of all, this is what's going to heat and cool your battery loop, and so you'll actually have thermal management of your battery packs. So no matter whether the truck is in Rhode Island in the middle of the winter or it's in Arizona in the middle of the summer, you'll have thermal management for those high voltage batteries. And then the second major reason it's very important is this is also going to provide heating and cooling to the cabin. One of the major reasons that the trucks are being made electric is so that you can run the HVAC without the motor on and running, or the engine on and running. This thermal box will run and pull power directly from the high voltage battery packs. So that's what's going to allow you to have your cabin hot or cold, regardless of whether or not the motor is on or running. The motor won't be doing anything while the vehicle is not in motion. So it's very important for those two reasons. Inside of this, you have your high voltage heater, and then there's also a compressor, a high voltage AC compressor, some chiller blocks, and some other tubing and routing for running these two systems. But this essentially replaces all your HVAC that you would have in your internal combustion engine. And then this will integrate in with the Ford blower and controls that are in the cab as well. So you'll see a lot of different connections on the front end of this box to the batteries, to the HVAC for the cabin. You've got liquid lines, you've got high and low voltage connectors as well. So the back of the thermal box, you can see there's high voltage connectors here for the heater and the AC, and then this runs out to the compressor itself. So there's not a lot on the back side of this, but this is where you're going to pull the high voltage from the battery packs to go into the thermal box. Again, heating and cooling batteries, heating and cooling the cabin of the vehicle itself. This is going to be your high voltage junction box, or otherwise known as the HVJB. You're going to hear a lot of acronyms in the electrification world. Government's happy and functions well with acronyms. So this is your HVJB, or high voltage junction box. And its purpose is to take the DC power from the battery packs, the hyper packs, run that to the accessories that are plugged into this, namely your HVAC heater and cooler and AC unit, namely your heater, your high voltage heater, and your AC compressor. Now you'll also have the charger, your OBC or onboard charger, that will be connected to this box as well. And then there is a final port for any accessory, any other high voltage accessory that you may want to run. So this is called the 4-port high voltage junction box, or HVJB. This is your inlet for your DC power coming from the batteries. And then this runs to your inverter for the motor. So this does all your high voltage switching. There's contactors, pre-contactors in here, and a fuse. Each of the Hyperpacks have negative contactors in the packs themselves, integrated into the packs. This has got your positive contactor here. It's also got low voltage communication. We'll show you that on the other face here in a minute. But this is what is actually part of the high voltage interlock and your IMD, which is monitoring all of the isolation faults or any system or any faults that are outside of the normal parameters. So when you go to power this up, this box is very important to that process, and if there's anything that's outside of the safety parameters, then it will not allow these contactors to close and therefore not allow the high voltage to flow. So that's its main purpose, is to do the high voltage switching, provide power to the accessories as well. This is the other face of the high voltage junction box, or HVJB, and you'll notice that there's low voltage communication here, and that's integral to the high voltage interlock system, or HVIL, and that safety system. And then these are your 4 ports on the high voltage junction box, which your accessories plug into. And you can see that it says this is for your charger, this is for your heater, and this is for your AC compressor. And then you have a final port there that could run any other high voltage accessory. In the future, there may be things that we want to run in addition to the HVAC system and your charger. We can do that through the high voltage junction box. That covers the high voltage junction box, or the HVJB. This is the PMU-15. You'll have 2 of these devices. They're low voltage, and they take care of some of the powertrain low voltage functions as well as the body controls. So you'll have 2 of these units that will be in the vehicle, and they're there to do either powertrain or body control functionality on the low voltage side, the 12-volt system side. This is known as the vehicle control unit, or the VCU. Its function is to serve kind of like the ECU would in an ICE engine, but this is actually going to control all the vehicle controls, and this is basically the central processor or computer for the Hypercraft powertrain. This is going to take signals from the battery packs, the BMS in particular. It's also going to be what processes the controls for sending signals to the inverter or motor controller on the motor. So you'll be able to go into this single unit, and Hypercraft will have a calibration on there. This is where the calibration lives, and you'll be able to do torque commands and the set high and low voltage limits on your cells, understand what the battery temperatures are and voltages, and it's also what's processing the state of charge. So when you get in, you can see how much battery life you have in the system itself. So again, this is the vehicle control unit, or the VCU, and it's sort of the brains or the computer for the whole system. So next we're going to talk about instrumentation. And in this case, we've got what's going to go into your vehicle. This will be a logging dash that's going to capture the data of the system. And this won't be necessarily what you're looking at. We're going to strive to make sure that just your stock instrument cluster is what you see and what you interface with. But you will be able to get into the logging dash to pull any diagnostics that are necessary. And this will be located somewhere in the vehicle. We haven't decided that yet, but eventually it'll be in the CAD model, so we'll understand where that is and we can point it out to you. Then you're also going to need a way to select gears. In this case, we're also going to try and program the normal shift lever that's stock to the F-150, but essentially it's a CAN bus controlled PR&D pad that allows you to shift from park to reverse to neutral to drive. So these are some of the controls, and these will be integrated into the system, and we'll talk more about where those are located once they're in the CAD model. But this gives you at least some nomenclature and definitions for what the display is with logging and what the PR&D pad is, so that you can select your different gears for your vehicle. Next up, we have the throttle, which fortunately the Ford stock F-150 truck of that generation, it comes with an electronic throttle, so we'll be able to use the throttle that's already in the vehicle, but just know that's what's sending the signal to the electric motor, the inverter, the VCU, working together to give whatever torque commands are required so that you get the performance, and you just operate that like normal, apply pressure, and then switch the brake pedal, which will also be stock as well. We're going to take just a minute and talk about a couple of other devices that you'll see, and then talk a little bit about safety. One of the first things that you'll interact with is going to be the J1772 charging receptacle. So this will actually be located in the vehicle, most likely in the gas fuel filler cap. And you'll just open the dust port like this, and you'll go ahead and plug in the normal wall charger that you'll be able to have from us, that we'll include with your system. But any J1772 plug will plug into this, and you can charge at either that level 1 or level 2 rate.